Hello guys, welcome to first law of thermodynamics, relation between Cp and Cv. Now let's say we have 1 unit mass of our gas and it's at a system at, let's say, PVT. Now first it goes through a constant volume, so it is isochoric process, right? So for this one, well, the volume doesn't change. So for this one we have some heat supplied, which is dq1. Now for the first one, well, from the first law of thermodynamics, we have dq1 is equals to du plus dw. So from here, we know if in isochoric process, dv is equal to 0. So here dv equals to 0, meaning that the small work done equals to pdv, well, is 0. So therefore, dq1 is just equals to du. Now also, in isochoric process, the heat supplied is equals to ms dt, and here some uh, temperature has been risen from original temperature, so the change in temperature is dt, let's say. Now this will be equals to ms dt 1, sorry, ms dt, which is, well, m is 1 and s is cv, this is d cv dt. So therefore the change in internal energy is cv dt. Now let's say from the original system again, we have, well, isobaric process, and we have some heat supplied, let's say dq2, such that we have the same rise in temperature. So we have dt as and here for this process there is some, well, some change in volume, which is dv. Now here in the second one, again we have dq2 is equals to du plus dw. Now for this one, dq2 is equals to, well, from this we have cv dt plus dw. Now again we have dq2, which is in isobaric process. So dq2, I'll write it here, dq2 is equals to, well, ms dt again, mass is 1, and for this one specific heat constant is cp dt. Now we put that in here, so we get cp dt equals cv dt plus, well, we know from here dw is equals to pdv, so this is pdv, and cp minus cv whole dt equals to pdv. Now essentially we just want to get cp minus cv, so we somehow have to remove the change in temperature. Now we know in all of these thermodynamics processes we take an ideal gas. So let's just take our ideal gas equation, which we had done in 11th grade chemistry. So from here we have from ideal gas equation that PV equals to nRT. But since the number of moles, well, is 1, unit mass, so unit mole also is equals to RT. Now let's differentiate both sides with respect to T, because we have dt right here. So we have d by dt is equals to d by dt. Now here in isobaric process, the pressure is constant, so pressure goes outside, dv by dt is equals to, well, r, because this is also constant, dt by dt, which is just 1. So we have pdv equals to r dt. Now we can put that in here, getting cp minus cv dt is equals to r dt, meaning this cancels, therefore cp minus cv equals to r. Now this is known as the molar specific heat constant. And now if we divide everything by, let's say, the molar mass of the gas, we get our principal specific heat constant. So I'll just write it principal like this, principal, and these two is our molar, specific heat constant. And we need this for our numericals, and this is it for the relation between Cp and Cv. So yes, if you learned something new, Please like and subscribe, and thank you.